Hello everyone, wishing you all a very good morning. I hope everyone is in the class. And as we discussed in the last class on Saturday, we have finished Newton laws of motion and friction. In today's class, we would start with a brand new topic, and that brand new topic is known as WPE. W standing for work, P standing for power, and E standing for energy. So the name of the chapter is work, power, and energy. We will be discussing these three terms. They are related to each other. They are related to each other. They are not audible. What is the problem? Everything is working on my side. Let me check. Am I audible or not? Hello, hello. Hello, hello. Let me check. Hello, hello.
Recording in progress.
I am audible. There is something wrong on your end. Please check. I am perfectly audible, perfectly fine. Nothing is wrong from my end. Please check the sound system at your end, beta. I have checked the sound system from my end. There is no problem. So I would request you to check the sound system from your end. There is nothing wrong at my end. Okay. Please check it from your end. Sound is coming from my end. Work, power, and energy. Anyone else in the class that can confirm whether my voice is coming or not? Okay, I can't help it. My voice is going. I don't see anyone. That is the problem. I hope someone sorts that problem out. The first thing that we are going to do is work. What is work? Now, work done in physics is somewhat different to what we think about work done in physics. I got confused. Work done in physics is somewhat different to what work done in daily life means. In daily life, right now, I am taking your class. I am doing some work. You are attending the class. You are also doing some work. I am lifting this pen and I am moving it like this. I am doing some work. But work done in physics, it's somehow a bit different. It is a bit different to what we understand about work in our daily life. Abhiram, Naresh, am I audible to you? Beta, can you just confirm whether I am audible or not? Okay, I'm audible. So please check the audio from your end. Okay, so work done in physics is somehow different to work done in your daily life. For example, if someone is having a heavy load on his head and is moving on flat ground, we all know that he is doing work. Yes, he is doing work. But if I talk in terms of physics, that work is not done. Yes, who is this?
Hello,
Yes,
sir.
beta. Yes, beta.
My name is Nagesh, sir.
Yes, Naresh.
Sound is not audible, sir.
But I can't help it. Sound is going from my end. Check from your end.
You're from okay, sir.
Yes. Abhiram, can you hear me? Check the sound from your end. Your end, there is a problem. Not from my end.
Okay. Okay, sir.
Please check it from your end.
Okay.
Okay. So what I was saying was, again, I got distracted. Work done in physics is somehow different to work done in your daily life. If someone is having a heavy load on the top of his head and is moving on horizontal ground, definitely he is doing work, but in physics, that work done is actually zero. So it is a bit different to what we think about work in your daily life. Now, to understand what is work in physics, we'll have to understand the definition of this work. Now, I can't see you, but I can still ask uh, if you can hear me. Do you have any idea about what is work done in physics? Do you have any idea what is work done in physics? How do I define work done in physics? Any idea, anyone? From the online class, Naresh, offline class? Any idea what is work done in physics? How do I define work done in physics? Obviously, this chapter work done has come after force and Newton laws. So definitely work done has got something to do with force. Can anyone tell me what is work done by a force? A force only does work. Anyone had any idea? No one has any idea about work done? Okay. Now, whenever you apply a force on a body, and if you, whenever you apply a force on a body, and how do you define force? Force is nothing but a push or a pull, which can either change the size or shape of the body, or it can make the body to move. So it can change the state of rest, it can change the state of motion, or it can change the size or shape of the body. That is what we know about force. Now, when you apply force on a body, either the body, the motion will change, or the size or shape will change. Now, size or shape is not going to change in this chapter. It will change in a chapter known as elasticity. Then we will see what happens to force over there. But no matter what I do, if I apply a force on a body, that force is going to do something. Either it will change the state of rest or the state of motion, or it will change the size and shape of the body. In any case, it will be doing some work. Now, changing the size or shape is a different topic altogether. We are not going to go into that topic. Right now, what we are going to understand is, if I apply a force on a body and the body moves, the state of rest or state of motion is changed. How do I calculate the work done by that force? How is work done by the force defined in that case? How it is defined? Work done by a force whenever, so I hope you are writing it, whenever a force is applied on a body, whenever a force is applied on a body and the body moves, and the body moves, work is said to be done. Work is said to be done. I hope I am audible and visible to all of you. Can't see anyone, but I hope that you can see me and hear me. Whenever you apply a force on a body and the body moves, work is said to be done. And here we are not considering the case where the size and the shape of the body is going to change. We'll do it in a different chapter. Say, for example, this is a flat surface. You have a body of mass m kept on the surface. You apply a force F. on this body. It does not talk about friction and all that. We apply a force. Friction is also a force. When the body moves, friction also does work. Let us not talk about friction now. Force F is applied on the body of mass m, and this body moves. Let us say that it moves by a very small distance, or it has a very small displacement dx. If you don't want to call it dx, let me call it as dr. The displacement of this body is dr. It moves like this, and the very small displacement of this body is dr. Then how is the work done? By this force defined. The work done, now since it is a very small displacement, the work done will also be treated as very small. Work done can be represented by the letter W. I will represent it by a different letter though. I'll add something, but let us not go into it. Work done may be represented by the letter W. So small work done can be represented by dW. D means very small. Derivative D. Small work done by this force in moving this object by a small displacement dr is given by this formula. The small work done is F dot dr. F dot dr. Now, a new thing comes here, dot. I think I have already discussed this dot product with you. This dot is known as the dot product. Remember, remember what to remember. Force is a vector. Dr is displacement, that is also a vector. But work done is a scalar. Work done is a scalar quantity. Two vectors combined to form a scalar quantity. How we can get a scalar quantity from two vectors? There is only one way, and that one way is known as dot product. We have already discussed this dot product, yes or no? Can anyone confirm whether we have discussed this dot product and whether you know this? Naresh, Aviram, yes, we have discussed this dot product. We'll again go and revise this dot product. Don't worry. Force and displacement are two vectors. When I take the dot product of these two vectors, I think we have also discussed work done when we were discussing dot product. Right now is the time to understand the definition of dot product as well as work done. Work done, small amount of work done, dw is the dot product of force with a displacement. Don't say it is force multiplied by displacement. No, force is a vector, displacement is a vector. You can't say multiply by force and displacement. You have to always say F dot dr. That is your work done. This is the small amount of work done. If I displace it by a large amount, the displacement is large. How do I find the large displacement? How do I find the work done when the displacement is large? I integrate it. Now, once I integrate it, I have integral over dw, integral over f dot dr. And obviously, I have some constant terms coming. Let us not get more into maths. Let us just concentrate on to the physics part. So to get the total work done, I will have to integrate. When I integrate this, I will write it as delta W is F dot dr ka integral. I have not solved the integral on the other side, but I have solved the integral on the left hand side. Remember, I'm specifically using this delta here. I'm specifically using this delta here with work done. Not many books. I have not seen any books which use delta with work done, but I always use this delta with work done. Why do I use this delta? I will discuss it in probably this class or the next class when we are writing some important points about work done. Right now, if you don't want to use delta, you may not use delta. It is just a symbol. I'm just using it for my own reference. You can write work done W as integral of f dot dr. This is how you define work done by a force. Work done by any force is the integral of f dot dr. Whenever you apply a force on a body and the body moves, work is said to be done. How much work is done? Small amount of work done, dw, is f dot dr. Total work done, delta w, or w, is integral of f dot dr. Am I clear with this concept? Can I have some reason that we understand this? Great. Now, what are the important things that you must remember? There are 2 or 3 points that you must remember about work done. The first point is work done is a scalar quantity. Obviously, we know. Number 2, the SI unit of work done is joules or Newton meter. As you can see, it is dot product of force with displacement. SI unit of force is Newton and SI unit of displacement is meter, and therefore the SI unit of work done becomes Newton meter. You can also call it joule. Work done, SI unit is Newton meter or joule. So far, so good, no problems. But now let us try to understand this dot product, because we might have forgotten this dot product. So let us have a quick recap of this concept of dot product. Let us have a quick recap of this concept of dot product, because this dot product is going to come in this chapter. If you understand this again, it would be a very important thing. Now, if I have two vectors A and B, the dot product of B will be written as A dot B, and it will give me a number. The value of that number will be equal to magnitude of A multiplied by magnitude of B multiplied by cos of theta. You can also write it in this fashion. Magnitude of A can be written as A, magnitude of B can be written as B, A into B into cos theta. This is the dot product of two vectors. You can write it in any way, either in way 1 or way 2. Why it is known as dot product? Because whatever you get on the right hand side, whether it is equation number 1 or equation number 2, both of these things are numbers, both of these things are scalars, and hence it is known as scalar product or dot product. It is a pure number. In this thing, we see that there is theta. What is this theta? This theta is nothing but, you must remember, if I have this vector as A and I have this vector as B, theta is the angle between A and B vector. Do we remember this? Do we understand this? Can I have some raise hand that we understand this? Dot product A dot B is magnitude of A multiplied by magnitude of B multiplied by cos theta, where theta is the angle between A vector and B vector. Shall I move forward? Now, this cross product or dot product, since it is a number, you must understand that dot product is a number. Now, this number can be a positive number, it can be a negative number, it can also be a zero. What determines whether it is positive or negative or zero? Which factor determines its positive nature or negative nature or zero? Remember, A and B are magnitudes of vector A and vector B. So A is always positive. The magnitude of vector is always positive. The magnitude of vector B will also be always positive. Magnitude cannot be negative. There is only one thing that decides whether the dot product is positive or negative. Can you tell me what decides whether dot product is positive or negative? If you take out A and B from the equation because they are always positive, there is only one thing that decides the sign of dot product. And what is that one thing? That one thing is definitely the value of theta or the value of cos theta. So when it is positive, when cos theta is positive, when is cos theta positive? When the angle lies in the first or the fourth quadrant, or I can say that angle is acute. For acute angles, we'll have positive dot product. What do you mean by acute angle? If vector A is like this, vector B can be here. So the angle is acute now. This this vector B is now in the first quadrant, or it could be like this. Vector B could be here. Now it comes in the fourth quadrant. In both the cases, theta is acute, and you will have the value of dot product as positive. It is very simple for you to understand it. I've also drawn a diagram. I hope this makes this point very clear. When it will be negative. So now you can understand when cos theta is negative. When is cos theta negative? Theta must lie in the second and the third quadrant, or if you don't understand quadrant, you can call it as the angle is obtuse. What do you mean by obtuse angle? If vector A is like this, then vector B would be here. This would be the second quadrant, or vector B would be here, and this would be the third quadrant. You look at this angle theta, or you look at this angle theta. In both the cases, the angle is obtuse, and hence in this particular case, your dot product will be negative. Do we understand that? Can I have some raise hand that we understand it, sir? If cos theta is positive, theta is acute, dot product is positive, you can call it as positive. Else, if it is obtuse, it will become negative. When it is zero, obviously if A is zero, it is zero. If A is zero, there is no two vectors. If they are not, two vectors are not there, dot product will not come. So if A and B are not zero, what makes the dot product zero? Dot product can become zero if cos theta is zero, implies theta is 90 degree or 270 degree or any odd multiple of 90 degree. What does that mean? If I have vector A here, if vector B is like this, or vector B is like this, the dot product becomes zero. That is why I said, if somebody is holding, is having something on his head, and he is walking, the angle is 90 degrees between force and displacement. And that is why in physics, it is said that he is not doing any work, but actually he is doing a lot of work. That is how work is somehow different in physics and in your daily life. Do we understand this? Can I have some reason? Cos theta positive, cos theta negative, and cos theta 0 determines whether the dot product will be positive, negative, or 0. Shall I move ahead? Okay. Then if you have understood this, let us try to solve a question and get the value. Magnitude of vector A is 5 units. I am writing it as A simply. Magnitude of vector A is 5 units. Magnitude of vector B is 2 units. Angle between them theta is 120 degrees. Find the dot product. This is a straightforward question. Find the dot product. Give you a minute to do this. How will you get the value of dot product? Okay. Have you solved the problem? How do you do this? You just have to apply the formula and you should be getting your answers. Am I audible and visible? So A dot B is simply equal to A multiplied by B multiplied by cos of theta. Value of magnitude of A is 5. 5 multiplied by magnitude of B is 2 multiplied by cos of 120 degrees. Now, there are many ways of finding cos of 120 degrees. Either you can write 120 as 90 plus 30, or you can write 120 as 180 minus 60. Doesn't matter. You should get the value of cos of 120. I think the value of cos of 120 is minus half. I hope you can also get it. So 5 into 2 multiplied by minus half and 5, sorry, minus 5 would be your final answer. And that is the answer that we are looking at, minus 5 units. Do we understand this? Can I have some reason that we understand this? Hello, hello, hello. Okay, great. So that is how you have to do a question if it comes. Now, I hope everyone in the class has also done it. I give you one more on this and then we will move ahead. Now, in this question, instead of giving you the question in words, I will give you the question in diagrams. Oops. So I have one vector here and I have one vector here. Okay, this is vector A, this is vector B. And this is your perpendicular, whatever you call it. This angle is given as 60 degrees. Magnitude of vector A is 3 units. Magnitude of vector B is 4 units. The question is find the dot product of the two vectors. So here is the question for you. Find the dot product of the two vectors. Your time starts now. Simple question. Keep it simple. A dot P. How should you get the value of A dot B? I hope you have tried this. A dot B is simply equal to A ka magnitude, B ka magnitude multiplied by cos of theta. What is the magnitude of A? As you can see, magnitude of A is 3. 3 multiplied by magnitude of B. Magnitude of B is 4 units multiplied by 4 multiplied by cos of theta. Now, if you look at theta, this becomes your theta. How much is this? From here to here, it is 90 degrees. So from here to here, it will become 90 plus 60. So instead of writing it as 150, you can also write it as cos of, that will be easier, cos of 90 plus 60. You should be able to find out cos of 90 plus 60. Cos of 90 plus 60 will be equal to minus sine of 60. Sine of 60 is root 3 by 2, and from there you can calculate the value of this. So this will be equal to 3 multiplied by 4 multiplied by minus root 3 by 2, and hence you can get your answers. This will be 2, so your answer will be minus 6 root 3. That will be the value of dot product of A and B. How I have done this? Very simple. Put the formula, put the values, get the answer, stay happy. Do we understand this? Can I have some raise hand that we understand this? Okay, great. I hope everyone in the class is also able to follow. I am giving you 2 minutes to note this, and then we will move on to the next part. What is the next part? You would ask. And again, I will give you an important note. Now, I must have given you this before, but again, since we are revising it, I will give you again. Now you must remember I, j and k. I, j and k are unit vectors. If I take the dot product of I with I, or if I take the dot product of j with j, or if I take the dot product of k with k, this will be equal to magnitude of I 1 into magnitude of I 1 into cos of angle between I and I. Cos of 0 is 1. 1 into 1 into 1 in all the cases will be equal to 1. This is one important thing that you should never forget. Also, we would have discussed I dot j will be equal to j dot I. You reverse them, doesn't matter, will be equal to j dot k will be equal to k dot j will be equal to I dot k will be equal to k dot I, and this will be equal to 0. Why is everything coming out as 0? The simple reason is that angle between I and J or I and K, remember this, if this is I, this is J, then this bahar wala is K, all are perpendicular to each other, everything is perpendicular to each other, angle is 90 degrees, cos of 90 is 0, and therefore the dot product of I with J or I with K and J with K is always going to be 0. Can I have some raised hand that we understand this? Okay. Now, if you understand this, please note it down. That is the first thing. And then you can go ahead and solve this problem. I think this is question number 3. If my A vector is 2i minus 3j plus 4k and my B vector is I plus 2j minus 3k, you have to find me the value of A dot B. A vector is given as 2i minus 3j plus 4k. B vector is given as I plus 2j minus 3k. You are supposed to tell me the value of A dot B. Your time begins now. How to do this? Well, the note is already there with you. You have to use that note and get the value of this. What to do? How to do it? So I have to find out the dot product of A with B. So basically I put the value of A. A is 2i minus 3j plus 4k. I have to dot it with vector B. How much is vector B or what is vector B? I plus 2j minus 3k. Now how do I dot it? How do I multiply it? It's the same way as you multiply in your third standard. This will be multiplied by this. This will also be multiplied by this. This will also be multiplied by this. Then this would be multiplied by this. This would be multiplied by this. And this would be multiplied by this. One more. This would be multiplied by this. This would be multiplied by this. And this would be multiplied by this. It is not rocket science. It is simple maths. Third, fourth standard maths. So now I do the first thing. I multiply this yellow with yellow. So I dot I is 1, 2 on this side, there is 1 on that side. So this yellow wala thing becomes, this yellow wala things become 2. 2i dot I dot I is 1, 2 into 1 is 1, so it is 2. Now, if I multiply the rest of the things, for example, if I multiply 2i, if I multiply 2i with 2j, I dot j will be 0. So the answer would be 0. I don't have to multiply it. If I multiply again 2i with 3k, again I with k will be 0 and therefore the product will be 0. So though I don't have to multiply it, the rest of the things would be 0. Do we understand this? Can I have some reason that we understand this? So basically I just need to multiply I with I. The rest of the things would be always 0. Now I'll move on to the next thing. Minus 3j and 2j, because rest of the things would be 0. J into j is 1. Minus 3 into 2, that is 2j. Minus 3 into 2 is minus 6. So that will be equal to minus 6, the green one. The green one. Then I am left with the last one, 4k. 4k has to be multiplied by minus 3k because rest of the things will be 0. The pink one will be equal to 4 multiplied by minus 3, that will be equal to minus 2, and my final answer would be minus 16. So my A dot B becomes minus 16. Am I clear? Can I have some reason that we understand this? How I have done this? I have just multiplied them आपस में together. I dot I will be 1, rest all is 0. J dot J will be 1, rest all will be 0. K dot K will be 1, rest all will be 0. Then you simply multiply them, add and subtract depending on plus or minus, and you get your final answer. Do we understand this? Can I have some reason that we understand this, sir? Okay, we understand this. Now, I will ask one more question here in this question. Find the angle between vector A and vector B. We know the value of A and B. We know the vector A and vector B. Can you now tell me the angle between vector A and vector B? Your time starts now. Angle between vector A and vector B. The question is how? How will you do this? I'll give you a minute. Think about it. I will give my answer after 1 minute. How do we get this? So I will tell you the concept of this question. What is the concept of this question? Or how do I solve it? With what concept do I solve this? What is the concept? I have to find the angle. I have to find the angle between A and B. How do I do it? Well, it is very simple. Doesn't take rocket science. I know that A dot B is equal to magnitude of A multiplied by magnitude of B multiplied by cos theta. That is the definition of the scalar product. If I write this equation in a different way, I can write it as cos theta will be equal to A dot B divided by magnitude of A multiplied by magnitude of B. Now this is the concept to find out the value of theta. Once you know the value of cos theta, you should be able to find out the value of theta. I'll give you a minute to get me the answer for cos theta? How will you get the value of cos theta? It is very simple now. It is very simple now. We already know the value of A dot B. A dot B is minus 16. A dot B is minus 16. So one thing is already known. Now look at vector A. Vector A is 2i minus 3j plus 4k. From here, I can find the value of magnitude of vector A. Magnitude of vector A. How will I get the value of magnitude of vector A? Magnitude of vector A, if I write it like this, that will be equal to under root of 2 square, which is x square, plus 3 square. You can also write minus 3, doesn't matter, plus 3 square, which is y square, plus 4 square, which is z square. So basically, I have squared the coefficients of I, j, and k and taken the root. This is how you find the magnitude of any vector. Do we understand this? Can I have some raise hand that we understand this? Okay. You can just find the magnitude of this vector, and now it is quite simple. The magnitude of vector A, I'll simply write it as A. 2 square is 4, 4 plus 3 square is 9, plus 4 square is 16, 16 plus 9 is 25, 25 plus 2 square is 4, 25 plus 4 is 29. So magnitude of A becomes root over 29, and I can now put this value here. I can now put this value here in place of A. But what remains is to find the magnitude of vector B. Now, this is a very small task. If you have understood this, I'll give you a minute to tell me the value of magnitude of B. And I hope that I get an answer. What is the value of magnitude of B? Coefficient of I is 1, so 1 square, plus coefficient of J is 2, so 2 square, 1 square plus 2 square. Magnitude or coefficient of K is 3 or minus 3, 3 square, 1 square plus 2 square plus 3 square. 3 square is 9, 1 square is 1, 9 plus 1 is 10, 10 plus 4 is 14. So my magnitude of B becomes root over 14. I can now put this value here, and now I can have the value of cos theta. What is the value of cos theta? It becomes minus 16 divided by under root of 29 multiplied by under root of 14, and that is the answer that we are looking at. The value of cos theta is minus 16 divided by root over 29 multiplied by, in the denominator, root over 14, or you can write it as root over 29 multiplied by 14. This is the answer to find. This is the way to find the value of cos of theta. If you get the value of cos of theta, you can take the inverse of this and you will get the value of the angle theta. Do we understand this? Can I have some raise hand that we understand this? Well done. So this is all about dot product that we have to understand. I'll give you a minute. Please notice down. If you have any doubts, the mic is there with you. You can ask your doubt now. Okay, it seems that we are fine. If we are fine, then remember the name of the topic is not dot product. The name of the topic is work, power, and energy. And we are trying to understand work. Now, let us, since we have now understood what is work, let us now understand more on work. Now, we have understood the meaning of dot product. One thing that we have not understood is why I have used this delta wala sign. And as I told you, we will discuss this in the next class. Right now, let us try to understand how will I find out work done if the force is a constant force. Now, what do you mean by a constant force? So first write the heading, work done by a constant force. Work done by a constant force. This is the first heading that you are going to write. Work done by a constant force. Now, what do you mean by a constant force? By a constant force, we mean a force that remains same. The force remains same in magnitude and direction. It never changes. A constant force is a force that remains same in magnitude and direction. It never changes. The example of this constant force in this chapter can be taken as the force of gravity. The force of gravity. This force of gravity is always equal to mg. This force of gravity is always equal to mass into acceleration due to gravity, and it is always vertically downwards. So in this chapter, remember, in the coming chapter, gravity also will be a variable force. But in this chapter, gravity would be taken as a constant force because it is always taken to be vertically downward and the value is always equal to mg. Do we understand this? Can I have some reason that we understand this? This is an example of a constant force. Do we understand this? Here also, in the previous example, if we look at the force A, if I say A vector is nothing but a force vector, and if I say this B vector is nothing but it was also a force 2i minus 3j plus 4k, that was force A, force applied at A. I plus 2j minus 3k was force applied at point B. Now look at force A and force B. You have 2, you have 3, you have 4. All these are constants. Here I have 1 multiplied by I, 2 multiplied by j, 3 multiplied by k. All these are constants. They do not change. And hence A and B, the force or the vectors that we saw in the previous example were examples of constant vectors. If I call them as forces, they will be constant forces. Do I understand this? Yes or no? Please raise your hands. Do we understand this? So all these forces and gravity will be taken as a constant force. Now, how do you find the work done by a constant force? If I use the original formula, work done is F dot d r. That is the actual formula. We have an integral sign. We have an integral sign, but if the force is constant, this is the original formula of force. This is the original formula of force. But if the force is constant, what I can do is I can take the integral out. I can take, or that way, I can take the force out of the integral and I can take the integral out. I can write this formula for constant force as work done by a constant force will be simply F dot delta r, where delta r is the total displacement. Here what I have done is I have taken force out of the integral and I have integrated delta r. I have integrated dr. When I integrated dr, I simply got the total displacement delta r, and that is how I have achieved the formula for work done by a constant force. Remember, this red formula is only applicable when the force is constant. Do we understand this? Can I have some raised hands? The ऊपर वाला formula, which is formula number 1, is valid for all forces. It's valid for all forces. Whether the force is constant or variable doesn't matter. It is valid for all forces. This red one is only valid for constant forces. Do we understand this? Can I have some raised hand that we understand this? This formula, the red formula, can also be written in this fashion. This is magnitude of F multiplied by magnitude of delta R, which is the displacement, multiplied by cos theta. What is cos theta here? What is cos theta here? Remember, it's a dot product. Remember, it's a dot product. So if I say my force is here or my displacement is here, that would make more sense. If my displacement is here in this direction, and if my force is here in this direction, theta is the angle between them. The work done by this force will be F into dr delta R into cos theta. But remember, the red formulae are only applicable when the force is constant. But the blue formula, which is highlighted in pink, is valid for all types of forces. Do we understand this up till here, what we have done today? In today's class, we have seen what is work done by a force. Whenever you apply force on a body and the body moves, work is said to be done. If I apply a force F and the body gets displaced by a small quantity dr, the small work done dw is F dot dr, where dot is the dot product. Total work done is written as delta W. Why delta? Next class. Delta W is integral of F dot dr. Then we saw what is the work done by a constant force. If I have a constant force, then I can write the work done as F dot dr, the red one, or F into F dot delta R, where delta R is the total displacement, or we can write it as F into delta R into cos theta. We also saw what is the meaning of delta, what is the meaning of dot product. A dot B simply means magnitude of A multiplied by magnitude of B multiplied by cos theta. It is a scalar quantity. It can be positive, negative, or zero depending on the value of theta. If theta is acute, positive. If theta is obtuse, negative. If theta is 90, zero. This is all that we have done in today's class. We have seen the dot product and seen the definition of work done. I will wind up today's class here. The next class, we will be doing problems on finding out work done. If you have any doubts, you can ask me now. Else, the class is over. Take care and have a nice day.